Welcome back to the show. Today, we're diving into a fascinating intersection of gaming and artificial intelligence with a focus on the factorio-learning-environment, or FLE. This innovative framework allows us to both develop and evaluate large language model agents in the popular resource management game, Factorio. Now, if you're new to Factorio, it's all about building and managing factories. Think of it as a complex puzzle with infinite pieces. So why FLE, you ask? Well, it provides two unique gameplay settings, lab play and open play. In lab play, agents tackle structured tasks with fixed resources, while open play lets them unleash their creativity in building the largest factory possible. It's like giving a child a box of Lego blocks and saying, "Go wild." But here's where it gets interesting. Research shows that while models display promising short-horizon skills, they still struggle with spatial reasoning, getting the layout right, and managing resources efficiently. For example, in lab play, they can build basic structures, but falter in more complex tasks like manufacturing electronic circuits. Speaking of complexity, let's discuss the agent's life cycle in the FLE. Imagine an agent as a smart intern learning the ropes of factory automation. They observe their environment through output feedback, then they generate Python programs to execute their desired actions. Once they perform an action, they'll receive feedback on how successful they were. This ongoing loop of observing, acting, and learning helps them refine their strategies. Now, what does that actually look like? Picture this. An agent needs to extract iron from the ground. It places a mining drill in the right position, verifies it's working, and even ensures it has storage nearby to keep the iron. But if something goes wrong, like a coding error, it can reactively debug itself. Imagine having an intern that not only messes up, but figures out the problem and learns from it. Pretty impressive. There's also something called the agent architecture. Think of it like a coding skeleton that every agent follows. They operate in episodes, where each action is based on a conversation with the environment, capturing context over potentially 1,000 steps. This means our agents can remember previous actions and outcomes, which can lead to smarter long-term strategies. Oh, and let's not forget about tasks. Each agent has specific goals it needs to accomplish, formatted in JSON files. For instance, one task could be to create a factory that produces a certain number of iron gear wheels in a given time. The agent needs to strategize to meet that goal, which adds a thrill of creativity to the challenge. As we look into the performance of these agents, benchmarks reveal some exciting insights. For instance, the efficiency of direct API calls to the Factorio server versus using the Python interpreter shows that headless configurations significantly outperform those with a client, by nearly 74% in some cases. That's like upgrading from a bicycle to a jetpack when it comes to performance. Now, before we wrap up, let's ponder this. What does the future hold for AI and gaming like Factorio? It's an open question as we start to realize the potential of these agents not just for games, but for real-world applications in automating processes and solving complex problems. Imagine the possibilities. To summarize, we've explored the fascinating world of the Factorio learning environment, its two gameplay modes, how agents learn and adapt, their architectural structure, and performance insights. This reveals how gaming is not just a pathway for entertainment, but a powerful space for developing cutting-edge AI technologies. Thanks for joining me today. Until next time, keep experimenting and exploring the endless possibilities, whether in gaming or beyond.